Welcome to Space Oddities. Sorry we were a minute or so late getting on air. Had a few technical problems with our guests this evening, but we hope it will be solved. Anyway, welcome to Space Oddities. Thank you for joining us, if indeed you are, because we've actually changed our day to Tuesday, as you will know now, obviously, because it's Tuesday. We're really sorry that we've had to make this change, but because of availability on Monday nights, it was getting difficult to do on Mondays. So we've moved to Tuesday. So those of you who have joined us, thank you for doing so very much indeed. And welcome to Space Oddities. And I'm joined this evening by the usual motley crew of vagabonds, rogues, and ne'er-do-wells. And we've got Michael there. How are you, Michael?
Hi there.
And we've got Roger.
Good evening.
Good evening, down in deepest...
Deepest, darkest, cloudiest Sparkford.
Yeah.
Cloudiest Sparkford. Well, there you go.
Cloudy Sparkford. You don't even often hear those words in the same sentence. And we've got Daz. How are you, Daz?
Lovely, thank you. Nice to see everyone.
Yeah, nice to see you too. Lou over there in the States. How are you?
Yes, doing well. Enjoying a few clear skies for a change.
Oh, that's where they are.
Yes,
that's where they've gone. And we're delighted to welcome back to Space Oddities our old friend Brian Jones, but we don't know whether his microphone is working. Say something, Brian.
Greetings.
Hey!
Well, kick my ass. Right, there you go. Well.
Oh, thank goodness for that. It's amazing how often the old thing of switching it off and on again works. So welcome to Space Oddities. Lovely to have you back. For those of you who don't know Brian is the editor and publisher of the Astronomy Yearbook that he does every year, which is
I'll go get a copy. Sorry, I should have a copy with me.
Yeah, get a copy. You may also know Brian from his wonderful articles that he posts on our Facebook page on this day in, where he commemorates births, deaths, etc. of famous people in astronomy and other scientists. There you are. It's back to front. You've got your camera flipped.
What?
Yeah.
How the hell's that happened?
I don't know. But if you go into, I tell you where to go. Do you see the settings icon underneath the main screen?
Well, there's a microphone, disable camera, share screen, add source, and settings. Yes.
Yeah, go into settings.
Oh God. Right,
Yeah.
I've done that.
Excuse me, ladies and gentlemen. I just saw Brian out with this thing. Go into video. Click video.
Oh yeah.
You'll see at the bottom a thing that says mirror camera.
Yes.
I'll turn that off. There we are. And now try it.
Right. I'll just get rid of the thing. I am now officially backward. Anyway.
Yeah. Hey, that's it.
There we go. Now we can read it. We had fun trying to read your notes that you held up.
Yeah, we were trying to decipher your notes you were holding up to the screen backwards.
Oh God, yeah, sorry.
We got it in stereo now.
Yeah. Oh, Roger's got one there. Anyway, we're going to be talking to Brian about this year's Astronomy Yearbook.
Roger Hyman has got a copy.
I've got mine as well.
Yeah, Roger's got it. Yeah. Yes, I hope to be getting one soon.
Oh, that's 3 out of 6. And the rest, the excuses, I'm waiting.
You may notice, actually, last week we did the quiz, Brian, and there was a question about ring galaxies. And on the front of your yearbook is a ring galaxy, is it not?
Yeah, hang on, let me just get to I'll read you the full caption if you want. Hang on, to identify it. How come pages stick together?
Hoag's object.
Hoag's object.
Well, there you are.
Yes, there you go. I can't remember them all. Yeah. So, actually, the cover images are usually. I usually get Rod Hine to select them because he does the recent advances in astronomy article.
Right.
Right. I'll select an object, and it usually comes up trumps. Right. So he has with that.
Right.
So so there you go.
And in fact, Rod will be joining us on the program, on the show here in December to talk about Halley's Comet because it.
Halley's Comet.
Yeah, sorry.
God, man.
We have a Hawley among us.
Actually, just to justify that, both Samuel Pepys and Hawley himself quite often spelt the surname Hawley in documents.
Wow. So it must be true then.
Because it's the only phonetic lead we've got. They spelled it correctly as well, but that's how it was spelled. But it's phonetic Hawley, and so we know that that's how we pronounced it, as well as you can know anything from the 17th century.
Wow.
Oh, okay.
So it is actually Hawley. You can ask Alan Chapman. I'm sure he'll tell you the same thing.
Yeah.
You sure when he wasn't signing his name, he had a bit of a tremor, and it just looks like a wubby?
No. They didn't have trembling knees in those days. It's genuine. And in fact, there is. Where is it? If I can find it. Oh, here we are. Just excuse me. Going back to the 80s, a guy called Brian Harper, with a U, formed the Hawley's Comet Society.
Right.
Now, sadly, Brian Harper's no longer with us. But one of the stipulations of becoming a member, there's no fees. You could just say you were a member. Was that you pronounced the surname correctly? Hawley. Hawley.
I see.
Now, the thing is, the society went defunct.
Yeah.
So I thought, oh, what the hell? It's not due back for another 40 years. But I've started the Facebook group, the Hawley's Comet Society.
All right.
More of as much as in recognition of him as much as anything else. But I think it's about to pass aphelion. I forget the date.
It is.
Yes.
On December the 8th, which is why Rod's coming on the programme to talk about exactly that.
There you go then. That's it.
Yeah.
And if he pronounces it Halley's,
I'm sure he won't.
It bloody daren't.
Yeah, I mean, we have the same sort of problem here at Space Oddities with names because Roger is constantly trying to convince us that his name is pronounced Roger He-Man. But yeah. I mean, we don't go for it. Well, so anyway, we'll come back to Brian.
Yeah, I'm gonna say this.
It could be Highwayman.
Yeah, probably was.
Don't let me get started on Uranus. You got to watch how you say that these days. But anyway,
absolutely.
Sorry.
Anyway, we will come back to Brian and talk about the yearbook in a little while. Also on tonight's show, we have a Q&A session for you viewers. So those of you watching, please, any questions you want to ask the panel, please put them in the chat, and we will do our level best to answer them for you. Any question you've always had about the universe, or like the universe and everything, or any questions at all that you'd like an answer to, no matter how ridiculous you think they are, or how facile, or how complicated, throw them at us and let's see if we can answer them for you. We'll do our best. So what we will do in time-honored fashion is to go straight to Mr. He-Man and a look at the night sky, and of course, in Rachel's absence, the viewers gallery. So, Roger, what have we had in this week?
Oh, clouds probably.
Yeah,
that's
probably
all I've been getting.
Mm-hmm.
So from the 19th to the 25th. So here we go. We've got first quarter over the latter part of the week. I can't show you any pictures of the moon or the sun this week because I haven't had a clear spell to watch any of it.
Oh,
So that's a first, but still, might be better tomorrow. But should there become any clear skies this week, we've still got the summer triangle of Vega, Deneb, and Altair dominating over in the almost overhead still. But Jupiter and Saturn are becoming still dominant. And we've also got the winter's constellations starting to appear more apparently in the night. So winter is coming. So we've lost the galactic core now, the Milky Way. But during the wee hours of the morning, just before sunrise, we've got Venus and Mercury, which is still quite low on the horizon. But if you've got a good easterly horizon, then you might have a spot of a faint Mercury in the sky.
Right.
So, and that's down below Leo. And below Leo is the comet, which we've pretty much lost, really.
Yeah.
Unfortunately for us, but any survival images of that will be for the views of the southern horizon. So we have got a new James Webb image, and this is a high resolution look at Herbig Haro 211, which is a bipolar jet traveling through interstellar space at supersonic speeds.
Oh,
yeah,
wow.
that's fantastic, isn't it?
And who was that from, Roger? Sorry?
And that's 1,000 light years away. This is from the James Webb.
Ah, yes, it's the Webb, yes.
So,
because there's a similar Hubble image of that same object, but that's very different to the,
yeah, it's very different.
The
It's
James
very
Webb,
sort of dark and
amazing.
smoky at the centre there.
Isn't it?
Yeah.
The detail in those jets is amazing.
Yeah. Obviously, somebody's processed that rather nicely to get the definition of all the structure of it all.
You have to admit they're getting really good at that, aren't they?
Very much so. But that's all we've got from the James Webb. So I shall promptly go on to our gallery. So we have got quite a few images again this week from our members.
For which we thank you.
Which we thank you very, very much. And the first one we've got is from another one of our regulars, Michael Murphy, and a panorama of the aurora.
Oh, nice.
From Clifton on the west of Ireland with his Canon 760 and a kit lens.
Oh, wow.
And it will be. Have a look at this.
Oh, that's
wow.
That's lovely.
That's the way to see it.
That's amazing colour, isn't it?
Yeah.
Beautiful.
Well done, Michael.
When was that taken? Is there a date on the descriptive information?
It was the 12th of September,
so
a week ago.
Really? Okay. Because I see that we just got slammed pretty good by a solar storm with a G3 solar storm.
Yeah, that was
just last night.
And Kath was lucky enough to get some images from it. She's camping at the moment, not far from where I am, and she took some images. And again, it was just like this with the green and the pink. So she was really lucky to catch it because everywhere else around here is all clouded out.
And you can see the definition of Ursa Major just above the roof there.
Yeah, you can. Yeah.
Oh, that's true.
Yeah,
that's fantastic. 2 for 1.
See miser and old coal there.
Yeah,
absolutely.
Yeah.
Very clearly.
Well done, that man.
Yeah, didn't Kath suffer a rud with her tent though?
Yeah,
I wouldn't be surprised because the wind's been terrible.
I think I read that on Facebook that she had a rapid unscheduled disassembly of her tent.
Yeah, and she had just poured up some water and it went on her leg.
That's right. Yeah, she got sprayed with boiling water.
Yeah.
Oh dear.
I know.
I hope you're okay, Kath.
Yeah. Right.
Right.
So we've got one from Jerry DeLay. Clamshell in Cygnus with his usual setup and equipment, and this is what he's sent in.
Wow!
Oh, look at that!
Yeah, it's a nice structural detail in there,
isn't there?
Well
done, Jerry. Another winner. Don't know how you do it, mate. Well, I know how you do it because you give us the details, but
very nice.
Yeah. That's just to say if I tried to say it would work. Okay,
and one from down in Cornwall, the Delibole Slate Quarry. He's on another one of his outings out in deepest, darkest Cornwall here. So he's done a bit of light painting on the building to help get a bit of foreground interest there with a Samyang 14 and a Canon 600D. And this is what we got.
Oh, nice.
Oh, nice.
That is lovely.
Yeah, that's really pretty. That's good for framing. I'd put that on my wall.
Isn't it?
Yeah, because sometimes when people tend to do the the light painting, they tend to overdo it. So the
that's
building actually pops out and it distracts from what's in the background.
Is that Perseus I can see?
Yeah, I can see the Andromeda Galaxy above the roof line there, up near the top part.
All right.
Oh, yeah, I see.
Oh, yeah.
So I guess that will be the double cluster in Perseus there, won't it?
Yeah.
Hmm.
That's perfectly exposed, isn't it?
Very nice.
Yeah.
Well done.
Not too much light pollution there at all, fortunately.
No, absolutely. Nice one. Well done. Thank you for that.
And Kevin with some solar images. Back to his solar imaging again after his lunar imaging from last week.
Yeah.
And this was just 3 days ago. So this is a 14 image stat mosaic.
All right.
Conditions are pretty rubbish, he says.
Look at that. Look at that.
Wow.
Look at the prominences on that.
Oh, look at that. Yeah.
Wow.
That's lovely, that is.
Mm.
In H alpha.
Yes.
Yeah.
That is
Lovely.
stunning.
Well done.
And there's a very nice long filament on there.
Filament, yeah. It's all like about halfway between the centre and the rim. About 2 o'clock. About 2 o'clock-ish, yeah.
Mm.
Well, 1 o'clock and 2 o'clock. It's so long.
Yes.
But what date was this? Sorry, 16th.
Was the 16th.
Oh, that's right.
3 days ago.
Yeah. Because that filament didn't break off. But I'll be telling you a story about another one a bit later on. Where you see the active region in the middle, towards the middle, there was a big bit of action going on there, and I was showing you that bit later on.
Okay, right.
Yeah.
And here's a close-up of one of the prominences that he took from that image as well. One of the biggest he's seen for several weeks, he says.
Wow, look at that.
Oh, look at that.
Mm. He had put onto Twitter the animation of this, and it was absolutely astounding.
Yeah, I saw that. That was amazing. Amazing. We've got a lovely animation from Daz to show you in a little while. So,
yes.
Yeah, absolutely.
Not of Daz, but by Daz.
Well, yeah, by Daz. Yeah. I don't think an animation of Daz is suitable for consumption, really.
We haven't got to the 9 o'clock cut-off point.
No, we haven't reached the watershed. No. Although we have here, but not where you are.
All right. Okay. Here we go.
Here he is again. Look.
Yeah, before the clouds came in. Mm-hmm. So the Ghost of Cassiopeia, which is the first time I've done this in narrowband. Well, first time anyway.
Right.
And this is what we've got.
Wow, Roger, that's great.
Oh, that's nice.
Now that's Cap, which is the middle star of Cassiopeia. So it just shows you how close it is to that. It's a bit like the witch. Contrast, right? It's a bit like the Witch Head and Rigel, where they sort of get quite close together. But
but it certainly seems to illuminate that center part where the sort of like the towery bits are.
Yeah,
it really does bring that out. But that's lovely. In fact, you can actually see the ghost with that where it's been highlighted, sort of like floating through. The thing. So that's fantastic. Well done, Rod.
That was just done. That was just done in one night. So I just used a hydrogen alpha and the O3 filter on that.
Right.
So
Do you use the ASI Air in your system?
No, I don't have that at all.
Wow. And then you get pictures this good. That's pretty striking.
Thank you.
That is good.
Right. And last one, which is also one of mine, the Heart Nebula, but this is only a mono image because this is just the hydrogen alpha.
Wow.
Oh,
wow.
And I thought that looked just lovely as a black and white image.
It is. It's worth framing, that one. That's lovely.
Yeah.
So I've got the other two filters to go with that, but the skies are against me at the moment.
Right.
Everyone's blowing the clouds towards Spartford in revenge for all my clear nights, I think.
Yeah.
Never mind.
Well, thank you for that, Roger.
As always.
Thank you for your images, viewers. And don't forget, if you would like to send us your astronomical images, And we're looking for anything that's got the night sky in them, basically. So skyline, always welcome anything. Then please email them to spaceodditieslive@gmail.com. 1 image per email, please. And if you could mark or put the subject of your email as viewers gallery or something similar, as long as it's got the word gallery in it, I think we'll find it. And thank you very much for doing that. And we always say how much we are in awe of the quality of the images that you send in, and just keep up the great work, because we love looking at them.
Yes.
And some of them will appear on the calendar this year, because we plan to do another calendar this Christmas. We might even get some dates to appear on the calendar this year.
Oh dear.
After last year's debacle. So anyway, we will talk about that towards Christmas.
Yeah. As I said, Andy, those calendars from last year are collector's items. They're exchanging hands at 75p a throw. So yeah.
God, that much?
Yeah.
They're not exactly Sotheby's material, are they?
Yeah. Well, if I destroy the other two, then that'll double the price.
While we're talking about Christmas, then don't forget, Christmas is coming up. Some ideal Christmas. Sorry to mention the C word. Might be the Space Oddities T-shirts, and they are now available in a range of colours, 9 colours to be exact. £19, including UK postage and packing. Please add £10 for orders.
It's rather heavy. I would expect that for a sweatshirt or something.
Yeah,
it's chainmail. It's English. It's chainmail.
Yeah, that's right. It's good quality chainmail. You can scan the code here, and the details are in the description of this video. And also, you can buy for your loved one or friend, or even your enemy, at Christmas a Space Oddities hoodie. They are £35, including UK postage and packing. Again, please add £10 for foreign orders. You can scan the code here now, or you can click on the details that are in the description of this video. So, I mean, it may seem a long way away, but, you've got to get your Christmas buying soon. So, there we are. Okay. Before we come back to Brian, and we want to have a chat about his astronomy yearbook for this year, Daz, while we're on the subject of solar, we have got this lovely thing from Daz of the sun. So how did you take this one, Daz? It's a lovely animation.
Well, it's actually from a app called Heliosphere.
Right.
That we can't actually see it at the moment. It'll probably come on. Is it playing?
Yes, it is playing. Yeah.
Oh, I've got no vision of it. Can anyone else see it?
Yeah,
I can see it.
Yes.
Okay then. This is actually from an app called HelioView. And you can actually make videos of what's been happening on the sun. And you can also use a chronosphere.
Right, can you just play it again, Daz, because it stopped?
Well, it's not playing for me.
Oh,
What's his playing now?
yes,
it just moved
a
then.
bit jerky. That's all.
Oh yeah, because that's me moving the actual slider. That's a shame that didn't play. It was playing earlier on. We had no trouble with it at all.
The first time we saw it, the first time.
So are they actually photos? Are they actually the actual view?
It's actually, they're taken from the satellites.
Right.
And I think this one is from the SDO satellite.
Yeah.
And what I was hoping, if you put it up again, Andy, hopefully it'll play.
Yeah, let's try again. Okay.
Is
there we are. It's playing now.
It breaks away right towards the end. Now this was on the 16th, and you can also see the big filament just a bit further towards the limb that was in the image earlier on. But this was happened on the early morning of the 16th, and it's due to hit us tonight. As we said, we had a good display last night, but tonight should be even better. It should be even stronger. So if you do have clear skies, get your cameras out, point them north, and then just let it play and see what you actually get, or just take loads of images and see if you can actually capture this, because it's supposed to start late tonight and go into tomorrow morning. It's just make sure you just have a go. As we said, Kath down here in Shropshire was able to catch it last night. A beautiful picture she had. And just give it a go. But that was what it was. That flare that we saw, that filament that we saw break off, was actually the will be hitting us tonight, and it should be around about where I've just clicked on. Can you still see it?
It's stopped playing again.
Yeah, for some unknown reason, it's maybe it needs to go on a loop or something. But I'm hitting the play button, and it's not
doing anything.
Not doing anything. Yeah. So
anyway, what was the name of the place? The site?
Helio View.
Viewer, right?
Helio Viewer, sorry, yeah.
Yes.
There is another app which is a more advanced one called J Helio Viewer, but this one's good for just people to get to know how to use this. There is also a chromosphere in there that you can use, so you can see the ejections with the sun actually blotted out, so you'll see what's actually. Yeah, so it's just called Helio Viewer, and it's absolutely fantastic. I found it last night.
Okay, and the web address, is it helioviewer.com or .org?
I think it was
.org.
.org, yeah, .org.
Yeah.
Okay.
And you can play with it. The J Helio Viewer is more of a professional viewer. Is more of a professional type, and you can do a lot more with it. Yeah. But it's very good for playing around with. There's lots of free apps for any sun observation that you want to look at, including NOAA. Yeah, give it a go, because the space weather at the moment is very, very active.
Yeah, absolutely. Okay, thank you for that, Daz. Just a very quick one before we go back to Brian. We've got a Dark Sky Festival for you on this weekend, in fact. That starts on the 23rd. And it's the Brecon Beacons Dark Sky Festival 2023. All sorts of observing, and there's a planetarium and all sorts of events going on. And you can get your tickets from eventbrite.com. That's EVENTBRITE, eventbrite.com. And you can, I'm sure if you just search that for Dark Skies Festival 2023, you'll be able to find it. Lots of things going on. Of course, a lot of it will be weather permitting. So I know the weather hasn't been brilliant lately. So let's hope that they have clear skies for the festival this weekend up in those wonderful Brecon Beacon Mountains. So there we are. Just thought I'd mention that. And I hope some of you managed to go if you got interested in going to things like that. I'm sure that'll be a fantastic day for the family, and night, hopefully. So there we are. Okay, now, Brian. So, could you just, for those of our viewers who may not know, could you just tell us a little bit about the Yearbook of Astronomy?
How long have I got? 2 minutes?
A couple of minutes.
Yeah, just a bit of background. Well, the yearbook first came out in 1962, and John Guy Porter was the editor and Patrick Moore was the assistant editor.
Right.
In 1965, Patrick took over as the editor, and it became known as Patrick Moore's Yearbook of Astronomy.
Right.
And he edited it, and it appeared regularly every year throughout the decades. 30 years, 40 years, 50 years. And then I think Patrick must have fallen ill, or, he got John Mason to help him edit it. So there were joint editors for 2 or 3 issues. And then John took over, I think, 2015 on his own. I'm going from memory. Then 2016 yearbook came out. And by that time, the publishers had decided to print the yearbook or publish the yearbook in cathedral doorstop format.
Oh, right.
Yeah, I mean, ever since 1962, it had been the same size, same thickness, same everything. The publishers appeared, no fault of John's or Patrick's, but the publishers seemed to have taken it on themselves to bring out these huge books. And eventually, Macmillan, the publishers, in 2016 said, right, 2016, that's the last one. You've had it, no more yearbooks. And I heard about this towards the end of 2016, by which time there should have been a 2017 edition in the shops. Of course, there wasn't. But I just received an email from Pen and Sword Books in Barnsley.
Right.
And they just happened to ask me, because they knew I wrote books on astronomy. They just said, well, look, you know, you're a local writer. We're having an astronomy line. Can you suggest any astronomy titles? So I emailed them back and says, do you want to take on the Yearbook of Astronomy? And about 5 seconds later, they said yes. So that was great.
Wonderful.
But they couldn't bring out a 2017 edition.
Right.
Now, so what happened was, I thought, 2017 cannot go unmarked. People collect the yearbook. It's like they collect stamps, you know.
Absolutely.
So having an empty year was actually a non-starter. So if you just bear with me a second.
Yeah.
There we go. I should have got this down. With the financial support, as it were, because it went halves, from Richard Pearson of Nottingham, well, basically this was brought out.
All right.
That was put together from first concept to publication, self-publication, if you like. It was 3 months.
Wow.
And it's 100 pages, but people have accepted it as filling the missing year.
Yeah.
It's become accepted as, because the thing is, the unusual circumstances under which it was produced just make it a little bit different anyway. And of course, it's the same size as the old yearbooks were, you know. And then the 2018 came out, published by Pen and Sword, and so on. Then what's the ad infinitum? I don't want to tempt fate, but they've been coming out regularly every year. And so the 2022 edition was the Diamond Jubilee edition, and the 2023, 2024 have come out since then, and the 2025 should be going to typesetting probably in about 4 to 6 weeks.
Already?
Already. And the 2026 edition, I've got a full list of articles all lined up.
Wow.
Ready to commission, and half the articles for 2027, because people are just queuing up to write for the yearbook.
Oh, wow.
And it's brilliant. But this brings me round to something that I thought about last year. And when I write the yearbook, I get a budget, I produce the yearbook. Out of that budget, I pay all the writers, etc., etc. You get the idea. And I thought, well, it's not necessarily my remit to try and market the yearbook, but obviously I let people know it's come out. But I thought I'll take a more proactive role. So I approached 1 or 2 astronomical societies. I actually took a box of books to 3 local societies to sell, you know, at meetings. But I thought I'll take it a bit further. And I contacted, for example, Gary Yule at Salford.
Yeah.
And I said, look, Gary, I said, I'm doing this thing where I get the editor's discount. I can buy copies at a discount price. And if I buy 4 or more, I get them post free. So I thought, well, hang on a minute. What I can do is I can get societies to order copies for their members. So they take a list of members' names, and Fred Bloggs wants one, and whoever, and he wants one for Christmas, and all the rest of it. And you get a list of members who would like a copy of the yearbook, not at £19.99, 20 quid, but at 15 quid.
Yeah.
Delivered, no postage. I get a list from the society, and I order the books, and I pay for them at my discount. But I get them delivered to the person who wants them. In that case, Gary Yule at Salford. He takes them to the meeting, collects the money, and then I get paid back.
Right.
And I actually, I keep it as a selling price of £15 because it's a nice round. I actually get a little bit more than that off. So what I do is I ask for a little bit less than 15 from the person who's done the selling. So they make 50p a book extra for the society funds or whatever. I don't get any commission for this or whatever. I don't get royalties. The whole yearbook edition would have to sell out for me to get royalties, and there won't be anything to retire on. It's purely the joy of trying to get the yearbook out to a wider audience, obviously a buying audience.
Yeah, sure.
Because if people don't buy it, you know, it won't continue to be produced. Now, touch wood, Pen and Sword have said nothing about getting rid of the yearbook. I don't want to, you know, crack a doom and all that. But they haven't actually said anything about doing it. But I'm one of these people who thinks, well, I'll tell you what, I'm not going to give them the opportunity. You know, if budgets, whatever, and costs and things. So I want them to keep on doing it. And the best way to do that is to make sure most of the copies that are printed are actually sold.
Yeah.
Because it's a time-sensitive book. It's not like bringing out, I don't know, just a normal astronomy book, you know, a guide to the moon. Because that'll still be valid in 5 years' time.
Yeah.
The thing with the yearbook is that people keep it on their shelves because each yearbook, as well as all the monthly sky notes and lunar, all this lot planetary charts, there are also something like, well, over 20 articles. It's like a book within a book, and it's that keeps it on the shelves.
Right.
It is worth. I mean, people. Has anybody, I don't know how many people are listening to this broadcast, Space Oddities Live tonight. I know there's a few names in the. I can only see 6 pictures on the screen, but how many have we got actually listening?
At the moment, we've got about 20 at the moment.
Well, that's not bad. Yeah, it's just that if any of those 20 are members of societies within the UK, because it's UK postage, which is free. If anybody wants to take this scheme on for their society, there's no money up front. I pay for them. I get them sent to the societies. I only get paid when the person who ordered them actually gets the cash in their hand. Then they PayPal me the money or something. So, I mean, if anybody wants to do that, I know Michael does.
Yeah. I did the same last year.
Yeah. This is it. As long as the order is for at least 4, it's happy days. You know, free postage. It's a win-win. You know,
Absolutely, it is.
I actually announced it.
We have a question from Derek. How are you, Derek? He says, where can he buy the book, basically?
Well, it's available on Amazon, and it's also available from the Pen and Sword website. You just type in Yearbook of Astronomy 2024 and you go to it.
Can I just say that I announced your offer at Bromsgrove Astronomical Society last night, Brian. So I'm waiting for some orders.
Oh, that's it. Well, the thing is, in order to get them for Christmas, the orders can come in any time up till, well, at least mid-November. Well, probably even early December.
Yeah.
And they'll get them subject to there being a meeting after you receive the books, obviously. But it's best to get the orders in before, say, early to mid-November. And you'll have them for Christmas then. But thank you for that. That's absolutely brilliant.
Yeah.
So, but the thing is, to the best of my knowledge, and nobody's ever contradicted me on this, the Yearbook of Astronomy is the longest running astronomy book of its kind in the world.
Right.
I mean, you've got the BA Journal, that's been coming out longer, but that's a society publication. I'm on about books that you can go to Waterstones and pick it off the shelf.
Yeah.
You know, so as far as I know, it's the longest running. It's a British tradition in astronomy. It's a tradition, and it really needs keeping up. So, so I'm enthusiastic, and I put my hands up to that.
No, well done, Brian. Well,
thank you, Brian.
We wish you all the very best of luck. Can you just give us some idea of what articles you've got in it for the?
In the 2024. Well, I'm just looking at the back notes now. Reading this, blah blah blah. Let's have a look. You got recent advances in astronomy and recent advances in solar system exploration. Riccardo Giaccone, X-ray astronomy pioneer. Then we've got Things Fall Apart, Chaos in the Solar System, Communicating from the Edge of the Solar System, Astronomy in Antarctica by Michael Burton of Armagh.
That sounds interesting.
Tracking older artificial satellites, so 1 or 2 that have been up since the 60s. They're still there, you can still track them.
Oh, yeah.
The Inner Lives of Dead Stars by Matt Kaplan. and a triumvirate of telescope makers: Thomas Cook, Howard Grubb, and Alvin Clark. And so that's the bulk of main articles that are in there. But there's a couple more apart from that, plus the 12 short ones.
Excellent.
So,
excellent. I mean, they are a historical record as well, aren't they? Which is really good, and it's really good reference books.
This is it. I mean, the thing, what I like about the way that Pen and Sword publish their books, sometimes, I mean, we've all got books on the shelves, but some books feel really nice to hold.
Yeah, they do.
I cite that one as an example. If you've got a copy of that, pick it up and feel it. It feels like a book. It seriously, it's good quality paper. It's a good solid book, and I don't know if anybody's ever read that, but it's a good book.
No, I don't know that.
Yeah, it's a classic. But the thing with the yearbook, the way they publish it, it just feels like a good solid chunk of literature.
Yeah.
And it just feels nice.
Yeah.
I don't know.
I know exactly what you mean. I know exactly what you mean.
Brian, are you thinking of actually doing an audio book where you narrate it?
No. No, I cannot say no.
There's your answer.
My last just said I'd never shut up. I have no idea what he's on about. But anyway. It's but if anybody listening, if they want to do this for their, all I need from them is their email address, and I'll send the details. And as long as the minimum order is 4, there's no cash up front. It's a win-win. Yeah. As long as you know you can get the cash off the people who've given you the names as wanting one, but you know those people better than me. But yeah, it's just, I don't know, give it a go, because it's just a way of keeping it here. That's it. So definitely. So there you go. And somebody said, who was asking where they can buy one? Oh, yeah. There's also a Yearbook of Astronomy Facebook group.
Yes.
Right.
So if anybody wants to join that, I mean, some of you will already be in it.
Yeah.
But it's a Yearbook of Astronomy Facebook group. If you just type in Yearbook of Astronomy, it's bound to come up. I've never searched for it myself because I've got a link to it. But I'm guessing it would come up. By all means, join. Space Oddities. Somebody's put. It looks like a link to the purchasing.
I just put the. I've just
ordered it. Oh, look at this. Graham Turvey, I think you're great, lad.
Yeah. So if our audience tonight any of our audience wants to buy a copy, can we do your offer tonight if they send an order through to our Space Oddities address?
Yeah. Well, the order has to be. It's like Graham Turvey has just ordered a copy on eBay. That'll just be a one-off copy at possibly a discount price. I don't know. But the offer that I'm on about is one where I order a chunk of at least 4 books to be delivered to a society.
Right.
So I need to send an email to, I don't know, Roger He-Man or Hi-Man. I mean, are you a member of a society?
Yes.
I mean, if you want to give it a go, I can send you an email with the details. You either manage to do it or you don't. But would you like me to send you the email?
Go on then.
Okay. I guess we're friends on Facebook.
Yeah, you must.
Well, we're on the Space Oddities Facebook group.
Oh, right. Well, what I'll do is I'll just make a note of your name, and if I haven't got your email address already, I'll just send you a quick Facebook message to ask you for it. I'll send you the email, and then if you manage to do it, that's great. If not, thanks for trying anyway.
I can send it to you over Messenger as well, Brian. So.
Okay then. Yeah. If you just send me your email, and I'll just send you your email address. I'll just send you.
I'm a member of Bath Astronomers, and we got about 108 members.
Oh man!
So you might be in with a chance.
Yeah.
Well, this is it. Like I say, to get the free postage, as long as it's at least 4 copies, because that takes it over the free postage cost. You see?
Yeah.
You know what I mean? I mean, if somebody was buying it from Pen and Sword direct, they might only have to order 3 because they pay more for the book anyway. If it's over 40 quid, it's free postage. When I order 4 copies or more, it's free postage at the discount price, and I get it shipped to wherever free of charge. So that's the thing. So it's a no-brainer, really, you know.
Yeah.
But if you can, if you can just Facebook message me your email address, I'll send you the email, and then just take it from there. Fingers crossed.
And I've already had an email from you already, Brian.
Oh, you've already had one. Yes,
Yeah.
indeed. I'm sorry it's a bit long, the email, but I try and cover everything, you know.
Yeah.
And can I ask, Lou Mayo, are you in the US, I guess?
I am in the US.
Yeah. You can order it from the US distributors, Casemate. It's a book distributor, so you can order them from there in America, so you don't have to pay
Couldn't we
postage from the UK.
Can we just get it from Amazon as well?
Oh, you can get it from Amazon as well.
Amazon as well.
That's it.
I would think, yeah.
Indeed. So, but if anybody does get it and anybody's got any comments, they don't have to be good comments. There's a quick dig anywhere, or something could be improved. If you've got a suggestion or whatever, just let me know, and we'll try and make it so, as they say.
I just sent you Roger's email address in Messenger, Brian.
Oh, right, on Facebook message. Yeah. Okay, so I'll check that out when I log back on again tomorrow, and I'll get that away.
All right then. Brilliant. So thank you very much, Brian. Good luck. We all wish you the best of luck with this, because you know, as you said, it is a British tradition. We need to keep it going, everybody out there.
Indeed.
And Christmas is coming, and what better Christmas present could you want? So
somebody's just asked me what the other book was that I was showing. So can I just hold it up again?
Yeah, sure. That was Ian.
Nebulae and Galaxies.
There you go.
By Giorgio. Could you read the authors' names out?
Giorgio Betty and Margarita Hack.
Right, Giorgio Betty and Margarita Hack. Right, okay.
Actually, if I just show you something in here, in the days when, going back to the 60s and 70s, we've seen some pretty good astro photos tonight.
Yeah.
But what do you think? Back in those days, that's what you had.
Oh, wow, yeah. I remember those.
I mean, to my mind, there are a lot of images of, you know, from James Webb, from Hubble, whatever, tonight, some brilliant pictures. But I think for sheer romance, those, I don't know, there's something about them. You know, there's something about the old black and white images taken through the Hooker 100-inch or whatever, that's got a certain magic about them. And I don't know, maybe I'm old-fashioned.
Yeah.
Yeah.
So,
okay. So thank you very much, Brian. Lovely to see you, as always. You know that you can always drop in at any time. You're always welcome.
Yeah,
And
I'll do. Tuesday nights is a little bit easier for me.
Good.
So there you go. Oh, can I ask one question?
Of course.
Has the viewership, is that the right word,
Maybe, yeah.
gone up over the last few months?
Yes, it has, yes.
Good. Because what I've been doing, every Friday and Saturday, I've been sending out 50 or 100 invites to all my Facebook friends to join the page.
Oh, thank you.
So I send them at the weekends because that's when people go on.
Right, yeah.
More often. So I pick it Thursday, Friday, Saturday. And so, I mean, I don't know. So far, it's got to about 1,200.
Fantastic.
It just gets a habit. But if everybody does that, invite all the Facebook friends, is every 50 you invite, 49 won't bother tuning in.
No, that's right.
That's just the way it is.
That's right.
It's the more people you get, because this is a really well-run channel.
Oh, thank you.
Thank
you very much.
It is, you know, and even I fathomed out how to reverse the camera and put the back. I mean, you know, with help, obviously. Well,
thank
actually, you did it, yeah. But
yeah,
it just, I mean, things like this, they just need to be made. People need to be made aware of these channels because you can actually talk to people.
Yeah,
you know, and well, you can't beat that. It's a community thing. That's it. The community.
That's it. Yeah.
Well, thank you for being our Space Oddities pimp, Brian. That's very kind of you. So we are much appreciative of that. So thank you so much. And there we are. So Brian, you're welcome to hang around for the rest of the program. Obviously,
I'll do that.
Yeah, sure. Because we've got something really interesting now coming up from Lou. So Lou, what's it all about?
Well, I've been reading about this exoplanet, this planet around another star that with headlines like life, have we found life? The first detection of life outside the Earth around an exoplanet. Oh my goodness. So I thought I'd better investigate. And so in the title slide here, this object, this exoplanet is K2-18b. And if you all were present for our exoplanet series, you know that B means that it was the first planet around that star discovered. I just want to point out one character here, and that is the question mark after the word exolife. Okay, I am not declaring that we have found life outside the Earth, but there is some interesting observations and interesting data. So let's take a look at this K2-18b and see what it's made of. Okay, let's see. Maybe the better way to do it is this way here. There we go. Whoops. Let's go back one. There we go. All right. So I gathered a little data on this exoplanet. There's a catalog number for you if you need something to do late at night. You can memorize that. There have been a number of space telescopes observing this. Kepler detected it originally in 2015, followed by Spitzer infrared space telescope. Hubble has viewed it, both imaging and spectroscopically. And then more recently, James Webb has done some really interesting spectroscopy on this planet. So we'll be talking about all of that. It's called either a super Earth or a little Neptune. Okay, its mass is kind of somewhere in between there, about 8.6 Earth masses. I list here a surface temperature of 265 Kelvin. That's really reaching, I think, for me to say that, because it's not really clear what the surface is. We don't know yet if it's a rocky planet or a gaseous planet. So I'm just going to leave that number there, more likely as a cloud top temperature.
Right.
Its density is about 2.67 grams per cubic centimeter. Well, Earth is 5.5. Most of our outer planets in our solar system are closer to 2.5. So perhaps it is a gas giant. It's hard to tell. It orbits at about 1.6 AU, 1.6 times the distance from Earth to Sun, with a 33-day period, and it's 110 light years away in the constellation Leo, by the way. So it has a very fast orbital period, which means it's very close to its star. And K2-18 is the star. And that star is a red dwarf star. So it's a spectral classification M3V. And for those of you, again, who attended our exoplanet series, you recall that stars are categorized by temperature and color, O, B, A, F, G, K, M, where OB stars are hot, KM stars are cool. And so you can orbit fairly close to this star and not be too hot. In fact, it has about the same solar insolation, there's the same amount of solar radiation per square meter as the Earth does with our sun, with our star. So very interesting. Okay, perhaps that's all interesting, but it gets even more interesting. This is really something to watch here. I took this page right off the Jet Propulsion Laboratory Eyes on Exoplanets website. And if you haven't been to that, you should. You should go there. You can see any exoplanet. You can point to it. You can look at it in 3 dimensions and play with it. It will show you the planet, its orbital system, and its star, and give you information about all of that. We don't really know that the planet looks like that, so they just made that up. But
yeah, sure.
But it does appear that this is a water world. There is speculation that it has an ocean of water with a hydrogen atmosphere, and that's going to be important in a second as we talk about that. So again, on Eyes on Exoplanets, we can see the orbit of K2-18b. that it just skirts the inside of this greenish ring here, which is the habitable zone of that star.
Yes, it does.
That makes it even more interesting, right? Because the habitable zone is the region, the distance from the star that a planet is, where liquid water can exist on the surface of the planet, I guess, assuming it has a surface. So it becomes even more interesting as a possible harbinger of life, perhaps, or at least a habitable environment. All right, so let's keep looking here. Let's keep exploring this. Well, this is its star. As I mentioned, it's an M-class star, so it's a relatively cool star. The other thing, though, that we know about M-type stars is they're really flary. They have lots of solar storms. And so the thinking is that these solar storms heat up the atmosphere and cause the photodissociation of water vapor in the atmosphere to break the water molecule apart into its components. And that's why it has such a dominant hydrogen atmosphere. But as we'll see in a moment, that's not the only thing in the atmosphere. And by the way, I think the hydrogen was detected. I think the hydrogen, being a symmetrical molecule, you're going to have a hard time seeing that in the infrared. So I think it was detected in through something called collisional absorption, where you have the bonds between it kind of jarred a little as it collides with other species. And you can see that detection in the infrared.
Right.
Moving right along. Here we go. This is some of the original detection. I think this is from Kepler, showing the just showing the dropout in the light curve of the star as the planet orbits. So it's orbiting in the plane of our vision, and each of these different colored photometric curves are shifted, so they are one on top of the other, but they're actually taking place at different times. So clear evidence that there is a planet in that star. Hubble was able to detect water vapor, and it's done a few models, water vapor as clouds, water with a nitrogen atmosphere, water only, and so on. And so what you see in these two graphs here, you see the black dots with the statistical lines, vertical lines. That's the actual data. That's the observed data. And then you see different theoretical models trying to fit that data. And it's a little hard to say, given the accuracy and the standard deviation of these measurements. But perhaps water clouds would fit this data the best.
Right.
So clear detection of water in the atmosphere. Now,
this is the interesting bit. The really interesting bit.
I saved the best for last. This is an infrared spectrum taken by the James Webb Space Telescope. I think this is from the NIRSpec instrument.
Yes, it is. Yes.
You can see. We have a knowledgeable viewer here. That's great. You can see on the bottom the wavelength of light from 1 to 5 microns. And you see various features here that are identified. There's methane in the atmosphere, CH4 methane. There is carbon dioxide, that right in the middle there, that orange grouping there, CO2. And then over here, there's dimethyl sulfide. Well, it turns out that dimethyl sulfide is generated on Earth either entirely or next to entirely by biological processes. And so this all of a sudden makes K218b a real target of interest for NASA and ESA. And the detection is a little, the data is a little noisy. I mean, you're detecting an atmosphere of a relatively cool planet in front of a star that is 110 to 120 light years away, right? So it's a really delicate detection, but it appears to be a real detection, and they're going to follow it up to make sure that's the case. If it is, then we'll have to come up with some reasons for why dimethyl sulfide should be in the atmosphere of a planet orbiting in the habitable zone with water.
Amazing. Can I just ask a question, Lou?
Yes.
I see we've got dimethyl sulfide at between, 3.5 and 4 microns.
Yes.
But again at nearly 5 microns.
Mm-hmm.
Do you know why it's there twice?
Sure. These are molecules, and they have rotational and vibrational lines. So you could carbon dioxide, methane, dimethyl sulfide, any molecule, you're likely to see emitting and absorbing at various at different frequencies, depending on the mode of vibration or rotation that you're sensing.
I see.
It's not unusual.
Yeah.
In fact, you see multiple methane identifications on the left there.
Yes, indeed so. Yes. This discovery, if that's what it is, this detection, if you like, is obviously tentative. Do you know if there are plans for the web to go back and image it again?
There are.
Good.
There are, and I suspect there will be other instruments, both in space and on the ground, pointed at this, trying to verify this DMS identification. So I think we should just stay tuned. It's interesting enough that I believe there are already plans underway to observe it again.
So if it's observed again and the dimethyl sulfide is still there at the same wavelengths, so we can say it wasn't an erroneous detection. What does that actually mean? What's the significance of that? Would that be enough for us to turn around and say, in light of the fact that this is the result of a biological process, that we have discovered life?
Well, you can't say you've discovered life. At least NASA's not going to say that. What they could say is that they have some tantalizing indirect evidence that this planet could harbor life. Okay? Mm. And then you might want to go ahead and start building some photochemical models that include the methane and the CO2 and the water vapor, and start kind of comparing that to what you would expect if this planet harbored some form of life, either in a watery ocean or in the clouds in the atmosphere. So it's you have to be careful when you see something like this, but it's very interesting, and of course we are looking. So it's not like we want to reject things that we find that are suggestive.
No,
we need to explore them.
Because this, at the end of the day, as with anything like this, where we're, analyzing atmospheres of distant planets, it could be down to some sort of chemistry, naturally occurring chemistry that we're not aware of.
Right.
Yeah.
So you have to go methodically, step by step, to call out, CULL out, those arguments, until all you're left with is, at least from what we know of biology, is evidence of, not detection of, evidence of.
Because, the media has already, as you know, gone overboard with this.
Yeah.
And there are headlines like life detected on alien planet and things like this. And, that's how they sell copy. That's how they sell adverts.
The assumption that this world possibly has an ocean underneath the clouds is the fact that dimethyl sulfide, DMS, on Earth is only produced by life, and the bulk of that DMS in Earth's atmosphere is emitted by phytoplankton in marine environments.
That's right.
So this is why they. Could it be like we had with Venus that the penguins? No.
Phosphine detection.
The phosphine detection. could it be cloud based? Because this exoplanet is 8.5 times or more the mass of Earth. And it's considered to be what they call a high-scene planet, which usually you're considered to have, like you said, a hydrogen atmosphere and contain water, which could be as either liquid water or as in vapor. Because one of the things they have said is that they're a bit dubious about the results, and as we said, they need more information, more observation, because as you said, Lou, the star that it's Kepler is very violent, and they think it may be just too hot for the ocean to either be, the ocean will either be very warm, so it can't host life, or it may not even be water at all. It could be just vapor. So yeah.
Well, I would say two things. One, the tendency is to try to identify environments where you and I would be comfortable. And we know from our understanding of extremophiles on Earth that may not be the case for all life on Earth. In fact, it is not the case for all life on Earth. The second is that it's not clear from the pressures. This is a more massive planet. From the pressures as you move down in the atmosphere, whether there's a fine line between, say, an ocean and an atmosphere. There may be kind of just a phase in over time. So it's really fascinating. And
it really is.
I mean, as Ian in the chat says, it's also not consistently in the Goldilocks zone. It goes in and out. So that's an extra dynamic, isn't it?
It is, although we were certainly willing to consider the possibility for life on Venus with phosphine in the atmosphere. Sure. Venus isn't in the habitable zone.
Right. Well, that's great. So thank you very much for that, Lou. We'll keep you up to date on that. Just before we go over to Michael and then into our Q&A session, just got a few news stories for you. Unfortunately, I spent ages creating a presentation with this week's news, and when I saved it for the first time, Windows decided to destroy it instead. So I'll have to do the news verbally. That was a waste of a couple of hours' work. But anyway, just a few things. Many congratulations for India because their Aditya L1 solar mission has been successfully inserted into its trajectory towards L1. So it's well on its way to L1. And the spacecraft is already returning scientific results. So congratulations to India for that. SpaceX today. As you may know, SpaceX have been preparing the second orbital attempt to get their Starship and Super Heavy booster into orbit. And the American Fish and Wildlife Service has turned around and said before they are allowed to have a license from the FAA, they're going to conduct a full investigation, which, according to them, was some obscure regulation. They have 135 days to complete the investigation. They haven't started it yet. So, a few months. So the Starship will definitely not be flying for a few months. If they find anything that they object to, then, obviously that's going to go on for longer. But the upshot of that is that SpaceX are not going to be granted a license by the FAA until the Fish and Wildlife Service complete their environmental investigation. They're particularly worried about the impact of that new water deluge system that SpaceX used to damp down the flames underneath the incredibly powerful Raptor engines. They're worried about the impact of that water on local wildlife. So, unfortunately, no Starship flight this year.
Their worries are that the water used is basically tap water. They collect it in tankers from the local city, and of course the area around it has its own natural ponds, but they're brackish, and they're concerned about the salt content of these ponds being diluted, but also the water is treated that it could kill some of the the inhabitants of these ponds. So, I mean, it was cited when they first used the deluge system. They tested it, but I did hear something about that. SpaceX are considering putting catchment ponds in, so that water is captured. But we'll see. We'll see.
Well, they already have a couple of catchment ponds. If you look at the aerial shots of the orbital launch now, there are a couple of catchment ponds there already. But of course, the one thing that SpaceX cannot do is to spray the area with salt water, because that
that'd be the worst thing to happen.
Everything absolutely immediately.
But then again, it'd be adding to the salt content of the ponds, so then they'll be moaning about that. So swings and roundabouts.
So, but basically, the upshot is that unfortunately, there's going to be no second orbital attempts this year, not before Christmas anyway. So there you are. Okay, what else was in the news? Who remembers Tabby's star?
Oh, yeah.
Tabby's star.
They thought it had a Dyson sphere around it at one time.
Yeah, that's right. Tabby's star is the famous star that periodically undergoes huge dips in brightness, which have hitherto been unexplained. And they're not regular, and they're not always of the same intensity. But this star quite dramatically dims quite often. In a nutshell, there have been all sorts of explanations, like a swarm of comets, an extraterrestrial Dyson sphere around the star, dust, rings. All sorts of explanations have been put forward, but none have really matched the observations. Now, just to let you know that the James Webb Space Telescope has just finished imaging Tabby's star. It's been marked as a completed task. So the analysis of that data is underway. So hopefully soon we might have a better idea of what on earth is causing that star to dim. Has to be said, since Tabby's star was discovered to have this strange property, which was a couple of years ago now, it was the first. But since then, several other stars of similar spectral type have been found to have the same thing happening to them. But I believe Tabby's star is the most extreme, if I remember correctly. Anyway, we will keep you posted on the data when that comes in from the web. When it's been analysed, we'll let you know what has been discovered, because that should be really exciting to actually see that. A lot of the radiation coming from that is in the infrared, so that's why they strongly suspect dust as the culprit. But if it is dust, it's a weird cloud in a weird configuration that we haven't seen before. So we'll look forward to the data from the web for that. Anyway, that was it really. I think for the news, there wasn't an awful lot of news this week. Just before we go over to our Q&A session to finish the program, we will go over to Michael, because Michael, I think you have something to announce.
Yes. What I have is a public meeting from the Society for Popular Astronomy. Some of you might know that this society used to be known as the Junior Astronomical Society. They have a public meeting on the Saturday, the 28th of October, from 2 p.m. to 5 p.m, 5:30 at the University of Wolverhampton Science Park in Glacier Drive, Wolverhampton. And their main speaker is Professor Lucy Green from UCL MSSL on the Sun and the Solar Orbiter mission. So that's quite an interesting topic there, a popular topic, because the Solar Orbiter was launched a few months ago. So that would be an interesting afternoon, I would have thought. And it's actually a free meeting as well. There's no need to sign up. Just go along and have an afternoon of astronomy about the sun. It'd be great.
Great.
So
that's Saturday the 28th of October at the University of Wolverhampton Science Park in Glacier Drive in Wolverhampton. Full details are somewhere. So there you are. Okay. Wonderful.
Okay.
Thank you for that, Michael. Okay. So now, viewers, it's over to you. It's time for our Q&A session. So if you have any comments, anything you want to ask, then please put them in the chat, and we will do our very best to answer them. I hope this doesn't fall flat and we don't get any questions, but we thought we'd give you the opportunity, because we do try and do these Q&A sessions quite regularly. So anybody got anything they want to ask about anything? Well, not anything, of course. I can't tell you the meaning of life, the universe, and everything.
It's 42, isn't it?
42, yes. So anything anybody wants to ask? Anything at all? No, can't see anything.
We need some good thinking music.
Oh.
Ding 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 ding.
No, hang on. No, stop that behavior.
Can I ask a question then?
Yes, of course you can.
I've asked this so many times, I've never actually got what I consider a proper answer because I don't think there is one. We all know about the universe expanding, the expanding universe. And we've all seen the demonstrations about the stars and galaxies on the on the outside of a balloon being blown up and expanding as it's blown up. My question is, if the universe is expanding, what is it expanding into?
Right.
No wonder you.
I thought it was deep.
Wolverhampton.
Yeah. Very good. Yeah.
It's the answer to that one, Wolverhampton.
Yeah.
It's a little bit of a it's a bit of a meaningless question. It's like asking what's north of the North Pole. No, it's true. It's a bit of a meaningless question because you are seeing a mental image of the universe being contained within something, aren't you?
Yes, that's right.
But that's not the right way to look at it because the universe is not contained within anything because it is everything. Therefore, it cannot be expanding into anything else because it is everything. So,
okay.
Now I know that's not a completely satisfactory answer.
Yeah, it is life, the universe, and everything.
Well, yeah, it is. You can't have something that is separate from the universe. You cannot have a medium that the universe is expanding into because the universe is everything.
And Ian put something in chat as well, which isn't.
Because it's a shame because I did see a new paper that's been brought out that they've actually think that they've seen. Because everybody thought the universe is expanding universally in whatever direction you look at.
Yeah.
And of course, you've got the cosmic web where you can follow all the galaxy clusters where everything's joining together. And you get these nodules where all the galaxies are coming together. And then in between, you've got voids. And these voids were supposed to expand and become emptier and emptier. And they think that these are filling with dark matter and things like that.
Excuse me for one moment.
But now they've actually postulated that they think they've seen in the actual cosmic web areas where the cosmos is actually stopping the expansion in certain areas. I wish I'd read it now properly. But they're saying that it's not expanding as we thought all evenly throughout, because no matter which way you look, everything is the same. But now they think that they found these areas where it's actually the expansion is being stifled and the voids are not growing in certain areas, which could be another complex involved in the expansion. And of course, we did have, I think Andy touched on it last week when we were talking about the expansion of the universe, the Hubble constant and the so-called crisis. Well, they now know that, and what the crisis is that we measured the expansion of the universe using two methods, Cepheid variables and can't remember what the other one was now. But basically
supernovas.
That's it, type 1A. And we were getting two different answers. And they were wide enough to say that we don't know really what's going on. Well, James Webb has now come along. It's done its bit. It's looked at the galaxy, the early galaxies. It's looked at this, and it's decided that the Cepheid variable method is the more
reliable.
So now they're talking about is our theory about the cosmic microwave background, which is what also comes into play. Is this where the confusion lie, and do we actually understand everything that we think we do know, or about the cosmic microwave background, whether it is correct or it's not?
I think it's. I don't think it's quite correct to say that the Cepheid variable method is the more reliable. It's just that the web has verified that there don't seem to be any errors in it. I think that's more the case.
Right. Yeah, that's probably a better way of putting it. Yeah.
So there we are. Okay, well, we're going to move on because time is running against us. A good question from Bath Astronomers we have here. Will Chandrayaan 3 wake up after the lunar night? Thank you for that question.
That is a very good question.
I think it will.
I would like to think it will, but I heard something the other day that the components on there haven't been made to actually survive the actual temperature drops. If they do survive, then I think there's a very good chance that they will come back to life, and it'll be able to continue, and it'll be amazing if it does, because the batteries were fully charged when it was put to sleep. So if it does come to back, it can continue with the science, and we'll get even more. So
let's hope so, because if India can bring it back to life, can be resurrected and carry on doing science, it'll be not just for this mission, it'll be an enormous achievement for the future, because we'll know that spacecraft can be built which do survive the lunar night. So that would be really interesting, because I don't think we've had that before, have we? That sort of test.
No. Not on the moon, but we do, of course, on Mars.
On Mars,
atmosphere, but it's a very thin atmosphere.
So there we are.
So
I must answer Ian's question. Well, we must answer Ian's question. Talking about the universe, do we believe that steady state is achieved, that new material is popping up in the voids that are created in the expansion? Short answer, Ian, no. The steady state theory is dead as a doornail and has been for 50 years. So there we are. That's a quick answer.
And anyway,
that was a bit brutal,
but it's true. There's steady state theory is a non-starter, Ian. It died with Fred Hoyle, basically.
Yeah, bless him.
And Derek's put, I think, his answer in answer to my question: where is the center? I believe it's the center of the universe.
There isn't a center.
It's everywhere.
Yeah.
It's everywhere, because the Big Bang happened everywhere. It's just everywhere was incredibly tiny.
The universe came into all in one go, so there is no center of the universe.
Yeah. By the way, just a quick.
I think Brian wants to say something.
Oh, Brian, go on.
Oh, sorry, it's only a quick one. Has anybody seen that book?
No.
This is a cosmological comment. Right.
Oh, right. No, I haven't seen that one.
It's science fiction.
Yes.
The master. Oh, one of the masters. Arthur C. Clarke's the other. Anyway. But if ever you wondered what happened, perhaps, before the Big Bang, read the short story, The Last Question.
Okay.
Right, okay.
The Last Question. Isaac Asimov, 9 tomorrows. It's 9 stories about tomorrow. If you just read The Last Question, slightly tongue-in-cheek, but a word of advice: when you get to the last spread of 2 pages, cover up the last page. Don't be tempted to read the very end. But that's it. Just seriously, if anybody can read that, get a copy of that and read The Last Question within the next fortnight or something, then it'd be interesting to get your opinions.
And that looks like a Chris Foss illustration on the cover as well.
Oh, right. Hang on. I don't know. I'll have a look.
Yeah, looked very much like Chris Foss.
Oh, here we go. We got another question.
Oh,
okay. Let's have a look.
Oh,
what are you hoping from Vera Rubin?
Oh, wow.
Yeah.
Yeah.
Oof, that's going to be
No, it's not in.
lots of data.
Yeah.
Lots and lots of data.
And the data stream can cope with it all as well.
Yes, millions of email alerts, which is what we're predicting. We honestly don't know. This has never been done before in this way.
Yeah.
To be honest, thank you for your question, but Bath astronomers, who knows what it's going to discover. This is a first in survey telescopes.
Yeah,
So,
I mean, you've just got to look at Gaia, the way that revolutionized how we see the universe, and they're still going through the data on that. And of course, the Vera Rubin is. Are we in? Yeah. Oh dear. Oh, you can stay behind. It's the Gaia. They're still going through the data for that, and they will be for decades. And what's coming up with the introduction of not just the Vera Rubin, but the other big telescopes, is going to inundate us with data that's all got to be sorted through. Yeah, it's something to really look forward to. The sooner these get going, because unfortunately we're all getting on. We're at the tail end of things, so we need to. We need our answers. We need our answers soon. We need our answers sooner. Sorry.
Just to be give a little more information, Vera Rubin telescope is the new name for the LSST, the Large Scale Synoptic Telescope.
That's right.
And its job is to scan the skies with very wide coverage every night to see what has changed. So it could be a comet, it could be an asteroid, it could be a supernova, it could be things we don't expect. And so that's why there's so much data. And actually, I'm hoping that they are able to leverage AI to help them analyze this flood of data.
I'm sure they will. Yeah. Yes, indeed. It's going to scan the southern sky because, of course, it can't see the northern sky in Chile.
That's the best part too. But
Yeah. It's going to scan the southern sky in its entirety every 3 nights. It features the world's biggest digital camera that's ever been built, the size of a car. It's going to generate, they reckon, and I still find this figure hard to imagine, but I've seen it quoted several times now, that they expect it, when it fully gets going, to generate 2 million email alerts per night. And can you believe that? And these are all things that have changed since the previous night. And there's going to be, I can't remember how many terabytes it was, but a massive amount of data generated by all this. But this is what we call time domain astronomy, looking at things changing over time, which we've never really had the technology to do in a sort of a continuous way. And I think if I remember rightly, the initial observing run is 5 years, I think. It's either 3 or 5 years. You can find it on the website. I put a link to the website in the chat.
Can I say as well that Vera Rubin was an American astronomer who pioneered work on galaxy rotation rates.
Right. She did. Yes, that's right.
Which led to the discovery of the discovery of dark matter as such. And also Bath astronomers. Now I'm assuming this could be Simon.
Simon. Simon.
Yeah. Will Vera answer the unidentified astronomical phenomenon? In other words, UFOs. Well, they. Lou hangs his head in shame. And well, you never know. But
to repeat Andy's question, Andy's answer, no.
No, yeah. It's they said this about the James Webb. I mean, they're determined that they're going to find flying saucers and aliens flying around. Because I did see there's also with the interest in the USA at the moment, with the government releasing all this information about these UFOs, as I still call them, that Oumuamua has reared its head again.
No, that's been disproven.
Yeah.
We understand the physics behind it.
Absolutely.
Yeah. We know that, but they don't.
I just want to put a comment up by Gerard. Nice to have you with us, Gerard. Steady State is out of date, as was Fred Hoyle. Thank you guys for an excellent show. Tim Peake starts a new series tonight, Chanel number 5 on the Universe. So there we are. So yes, Tim Peake starts a new series on the Universe tonight on Channel 5. Thank you for that. Thank you for reminding us, Gerard.
Yeah, it actually started at 9 o'clock.
Yeah, starts at it's starting then. So there we are. Okay, well, that appears to be it in the comments for the questions for the moment. So I think as time has beaten us, more or less, I think we'll draw proceedings to a close. I'd like to give a big thank you to our old friend Brian Jones for being here again, telling us all about the yearbook. Don't forget, buy the yearbook, buy the yearbook, buy the yearbook.
Yeah,
that's the mantra for today.
I'll be in touch, Brian.
Be like Roger.
Thank you. Roger. There you go.
Here's Roger. Here's an astronomer. He bought the yearbook. Be like Roger. So there we are.
Roger Heeman.
Thank you all for joining us on a Tuesday instead of a Monday. Thank you for the coffees. As always, we will be back next Tuesday. And next Tuesday, we're delighted to welcome to Space Oddities Dr. Sam Morell. He is going to be telling us all about gravitational waves and an application called Chirp that he has been responsible for, where you can have the latest alerts about gravitational wave detections from merging black holes, colliding neutron stars, whatever, on your phone. And the Chirp was down for quite a while, but it's now back up, and Sam's the man responsible. And we'll be delighted to welcome him next week to talk all about gravitational waves. And there you are.
And the signals are coming in thick and fast. I was on there today.
They are, yes. And 9 tomorrow is by Asimov. Brian,
yes, don't forget the last question.
The last question.
The story inside the last question.
Yeah.
Okay.
And thank you for your support as always. We do appreciate it. And tell everybody ring random strangers in the phone book and tell them about us as well, because that seems to be quite effective. Anyway, just before we go, if you frequent our Facebook group, you may have noticed a big increase in the amount of spam recently. I'd like to give a big thank you to Brian, who's been helping me turf out the offenders and delete the posts. But we are under attack by quite a lot of spam on the Facebook group. I don't know whether it's just us or other groups. I suspect it's not just us. But I think a lot of this spam is being generated by AI and a lot of dodgy adverts with links that you definitely shouldn't click on. So be careful on Facebook. Facebook don't seem to be doing that much to control it, if they can. And there you are. So apologies for any spam that you see on the Space Oddities Facebook group, and we're dealing with it the best we can, but it's coming in thick and fast at the moment, and we just don't have the time to sit all the time monitoring the Facebook group for spam. We're doing what we can, but we don't want you to be subjected to any dangerous posts, obviously. There are a lot of fake adverts out there at the moment. And as I said, I'm sure a lot of them are being generated by AI. Okay. Lastly, next Sunday is the return to Earth of the OSIRIS-REx capsule with its, priceless, really, cargo of material from asteroid Bennu.
Mm-hmm.
And that returns to Earth. I think we worked out when it was, didn't we? I saw somewhere it was sometime in the morning.
Yeah, sometime in the morning for the USA, but it was the afternoon for us, wasn't it?
Okay, we will be covering that live here on Space Oddities. So join us on Sunday, and let's see whether we can get that capsule down into the desert and its precious cargo of material from an ancient asteroid in asteroid Bennu. Taken away safely for analysis. So we'll be covering that live from the desert here on Space Oddities on Sunday morning, and we hope you can join us. Keep an eye on the Facebook group for details, and keep an eye on the channel, because we will create the live stream beforehand, so you can see on the YouTube channel here when we're going to be broadcasting. So until next week, say goodbye, guys.
Goodbye,
guys.
Cheers.
And thank you again for your support. And we'll see you. If we don't see you on Sunday, we'll see you back here next time.
And keep an eye on the skies.
Yes, keep looking up.
Roger on commission.
Buy the book.
Buy the book.
Buy the bloody book.
Okay. All right. Take care.